Chapter 5, Day 5 is about the properties of logarithms. We're going to be using these properties a ton. So star them, highlight them, rewrite them down in your notebooks, do whatever you got to do. You want to make sure that you know all of these properties. We used them a little bit in Algebra 2, but make sure that you do know them because that's all we're going to be using today. One other point of emphasis here is the change of base. So another property for logs, which is really nice, is changing the base. So if you notice, we can take any log base A of x, and set it equal to, we can change the base to log base B by doing log base B, the new base, of the inside divided by log base B of the original base. Okay. One point where this is really helpful, if you remember, we used it yesterday at one point. If I have to find log base 5 of, let's just say 12, and it doesn't work out nicely, it's if I converted, it wouldn't really help me find this one. If I had to type this one in my calculator, I can change it to base 10 by taking log of that inside over log of the base. And now we can use the calculator because the calculator has a base 10 button. Okay, so that's one place where it's helpful. But again, the main point of emphasis for today is over here. Make sure you know those properties. We're going to be using all of them. And then also tonight on the homework. So if we take a look at the examples as we go through here, if they have numbers, we're going to try to evaluate the actual value. And if there's variables, we're either going to condense, meaning take multiple logs and condense them to a single log, or if there is a single log, we would be expanding, getting it as far out as possible. So the first 4, I believe, we're just evaluating. So the way we do this is rather than work with them all separately, again, knowing your properties. If I'm adding 2 logs with the same base, you can add those 2 to a single log by multiplying the insides. So again, I'm not just taking this out of nowhere. If you look up top, that would be the first property right there. If I have 2 logs with the same base being added, I can condense it to a single log by multiplying whatever is on the inside of those 2 logs. Again, going the other way, if I also had a single log and I wanted to split it apart, I could do that by adding the 2 logs separately with whatever's on the inside. So these do go back and forth. If we go through this, then we would have log base 10 of 100. And then we know log base 10, 100 is 10 squared. That's just an equivalent number. So again, here I'm using another property where if the base of the log matches the base of the inside, we talked about this one yesterday, but we can use this property base of the log matches the base of the inside. You're left with whatever that exponent is. So this would be equal to 2. Okay. For number 2, we're going to see it right off the bat. We see that these numbers match. So we're going to make this easier to work with by changing that square root to a 1/2. And again, now we're going to use that same exact property. Base of the log matches the base of the inside. This cancels, and you're left with whatever is in the exponent. If we take a look at number 3, similar to number 1, but instead of an addition, it's subtraction. So if you look at the top of the page, we know that when we subtract 2 logs with the same base, you divide the insides. Now make sure that whatever is in front goes in the numerator, and anytime there's something that's being subtracted inside the log, that goes in the denominator. So if we simplify this, that's log base 9 of 1/3. And then for this one, it's not quite as simple because we can't change this inside to have the same base as our base of the log. So what we're going to do is we're going to actually evaluate our log, meaning we'll set it equal to x. And if we can, let's convert to exponential and see if we can solve. By doing that, 3 squared to the x equals 3 to the negative 1. And we see that we can get these bases to match. So then we just set the exponents equal and x equals negative 1/2. And it's not x because there's no variable in our initial problem, so actually it's not x equals, but rather this whole problem, log base 9 of 25 minus log base 9 of 75, is equal to negative 1/2. When we look at number 4, we notice that they're similar in a sense to number 2. The properties up here, if you look at the last property that we have, if the base of the exponent has the base of the log, then you're left with whatever inside the log. So if we scroll back down here, remember natural log is base e, so these would cancel, you're left with 3, plus these would cancel, you're left with 2. But then on this last one, you have to be very, very, very careful, because if we look at this one a little bit closer, this is e to the log base e of e. So don't get in the habit of just rolling through it. These two cancel, but you are left with that inside. So 3 plus 2 is 5 minus e. Okay, so that's number 4. Now on to number 5. We notice that there's variables involved. So we have to look at two things. One, are we condensing or are we expanding this problem? Well, since we're starting with 2 logs that are separate, we're going to condense. And it should say in the directions, but if it does not, when you have multiple logs with variables involved, you can assume that you're condensing. But again, it will say, for the most part, in the directions. What it means to condense is we want to take all of the logs and condense it as much as we can into a single log. So the first thing we want to do is you can't add or subtract 2 logs until everything is inside their individual logs. So we notice this 2 is out in front. We can't condense it with another one until we get it to the inside. So if you look at the top, when we have a number in front, the way we can put it to the inside of the log is we kick it to the exponent of whatever is inside that log. Okay? And then again, vice versa, if there's an exponent inside the log, we can move that to the front, and then we get the second part. So you can go either way, but in this case, because we're condensing, we want everything inside those logs, we can move this 2 to the exponent of the x. And now, at least for that first term, we have everything inside that first log. For the second one, we would do the same thing. Oh, I'm sorry, we don't have that 3 anymore because we moved it to the inside. And now that everything is on the inside of those logs, we can use the difference property, which means when you subtract 2 logs, you can condense it to a single log by dividing whatever's on the inside. And now that everything is inside that single log, we would look to see if there's anything else on the inside that we can simplify, but there really isn't anything, so we can go ahead and leave it there. If we take a look at number 6, again, we're starting with multiple logs, so we are condensing. Nice thing about this one is there's nothing in front on the first one. However, on the second one, there is a 3, so let's go ahead and move that to the exponent. And then there's a 2 on the last one. So let's move that to the exponent of the other one. So we have log of x squared minus 16 minus log of, now be very careful, this 3 is going to the exponent, but it's going to the exponent of every single thing on the inside of that log, that whole expression on the inside. So it's x plus 4 quantity to the third. And then again, log of x squared. Now that everything's on the inside, we can go ahead and condense all of them to a single log. Anything that is after a subtraction immediately will go on the denominator. So let's go ahead and go to the big log. This is going to go in the numerator. But then, because this is right after, it's a term being subtracted, that's going to go into the denominator. But this one is being added, so this x squared is going back to the numerator. It does not go into the denominator just because it's after some subtraction. It's all based on the addition or subtraction of the log that it's referring to. So now we have condensed it to a single log. The final step here would be to simplify the inside. In this case, we can simplify it one more step, and that would be by factoring that binomial in the numerator. The difference of squares. And if you notice, the reason that was really helpful is one of our binomials will cancel, so that our final answer is log of x squared times x minus 4 all over x plus 4 quantity squared. And that is condensed into a single log. So now that we've gone through a couple problems, go ahead and pause the video and try this one on your own. Again, we have multiple logs, so we're going to be condensing these into a single log. If you notice, be very careful. These are parentheses here. So you need to make sure you take care of this -3 first, and then go ahead and finish condensing it, and then unpause the video and check your answer and make sure you got it right. So we're walking through this one. The number one thing you got to do first is you got to distribute that -3. All the same algebra rules we've used through Algebra 1 and Algebra 2 are applying here still, so we got to distribute that -3. And then I kind of did 2 steps in one. You can distribute it to the front and then move it to the exponent, because again, we got to get everything inside that log, and then again, you would go through that process of condensing to a single log and then simplifying the inside as much as you can. If we take a look at number 8, now we're going to be going backwards. We have a single log, there's variables involved, so for this one, it's going to ask you to expand the inside of that log. So we want to expand, meaning we're starting with a single log. We want to get everything out, as everything based on the properties, outside of the log as you can, and get as many logs as you can. Just because it's a natural log, nothing else changes. All the same properties that we're applying for our logs are still applying for the natural logs. So the first thing we want to do is we notice all of these are being affected by this square root. So let's go ahead and rewrite this as the natural log of x plus 1, x plus 2, over x minus 1, x minus 2. But all of these, let's make a big one, all of these are raised to the 1/2. Well, if you know your power rules, when we split this, all these can be to the 1/2. And the reason I say that is, again, when we're expanding, we want to get all of the properties out as much as possible. So if these are all to the 1/2, and I don't want to write them there, we'll rewrite it again. Natural log of x plus 1 to the 1/2, x plus 2 to the 1/2, x minus 1 to the 1/2, and x minus 2 to the 1/2. Now that they're all individual, we can go ahead and split this apart. Okay? So these are all being multiplied or divided. So when we split this, anything that's in the numerator is going to be a positive natural log. So it's x plus 1 to the 1/2. Plus, remember, when you multiply two things on the inside, you can add 2 logs. So if I went backwards here, 2 logs being added together, you would multiply their insides. So it's kind of showing the reverse of how this one's working. Now anything in the denominator has to be subtracted. So if we go ahead and put both of those pieces that are in the denominator and we subtract them, again, if I just take a quick second and look backwards, 2 logs being added, those would go in the numerator. Subtraction, that would go in the denominator. Subtraction again, that would go in the denominator, and then we'd be right back where we were on the previous step. Now the final thing here is, remember, we said that when we expand, anything that can go out in front or outside the log or split, we want to go ahead and do. All of these exponents have to go to the front. So we have 1/2 natural log of x plus 1 plus 1/2 natural log of x plus 2 minus natural log 1/2 natural log of x minus 1 minus 1/2 natural log of x minus 2. And this is our completely expanded natural log function. So again, if we worked backwards and condensed, just like we did on the previous problems, we would get that initial problem. On the back page, what I want you guys to do is go ahead and try numbers 9 and 10. And then when you're done trying them, go ahead and unpause the video and I'll walk you guys through the answers and the work. So if we take a look at number 9, again, first thing you want to do is go ahead and split these logs into 2. So when we split those logs, natural log of the numerator minus natural log of the denominator. Then we notice that 1/2 is in the exponent, move it to the front like before. And then you can see it in red here. This cannot be split anymore because, again, our properties state that in order to split something, it has to be multiplied in the inside to be expanded into the sum or difference of 2 logs. On the inside, we have x squared plus x plus 1. There are no properties for logs that state anything's being added on the inside can split to the outside. And then also natural log of 1 is a property. We said that it's 0. So then you're done there. If we take a look at number 10, again, it's a cube root, so that 1/3 applies to the exponent of the numerator and the denominator. And then you're walking through the rest, split it, and then move the exponents to the front. And again, like we said, 2 things being added on the inside of a log cannot split to multiple logs. So you're going to see a couple of these on your homework. Make sure you get the practice condensing, expanding, and evaluating as well. If we take a look at the last section here, it's giving us a key. It's saying log of capital A is going to be equal to lowercase a. Same for B, same for C. We're going to use that for 11 through 15, 11 through 14. So in order to do this, we have to first expand. So we know our rules here. Log of A minus log of 10. Remember, if there's no base, then the base is 10. Well, now that it's expanded, we can use this key. Well, log base 10 of A, capital A, equals lowercase a, and log base 10 of 10 is just equal to 1. So we've gone and rewritten this log in terms of lowercase a, lowercase b, and lowercase c. If we take a look at number 12, again, the first thing you got to do is expand it as much as you can. So we're going to go ahead and say log of 100. Anything being multiplied in the numerator is going to be added. So log base capital A of 2. Anything in the denominator is going to be subtracted. It's a 1/3 root. So minus log base 10 of C to the 1/3. You can't substitute yet because we do have these exponents up here. So these got to go to the front. Log of 100 plus 2 log of A minus 4 log of B minus 1/3 log of C. But now that we've got everything in terms of log of A, log of B, and log of C, these can be replaced by lowercase a, b, and c. We do know that 10 is 10 squared. So if this is a base 10, we can say that these cancel and you're left with 2 plus 2a minus 4b plus 1/3 c. And since they're not like terms, nothing is a like term, you can go ahead and leave it as that. Why don't you go ahead and try 13 and 14 on your own. And then when you're done, unpause the video and we'll go ahead and walk through those together. For number 13, again, just like we did, expand it. We have 5 log of A plus 5 log of B minus log of C. And then again, use that the key at the top of the problems to replace log of A, log of B, and log of C. For number 14, you only need to split the second one. The first one is equivalent to A. When we split it, this 2 does apply to both the numerator and the denominator. Because when we split it, that log of 1 over A splits to log of 1 minus log of A, but that 2 is being multiplied by both of them. So it's 2 log of 1 minus 2 log of A, and then you can go ahead and finish with the key there. So that's rewriting a condensed log or an expanded log in terms of variables. Again, you'd be given that key like we have at the top of this problem set. So go ahead and work on the homework. Again, if you have any questions, please feel free to reach out to your teachers, and good luck.